Hello everyone. The topic which we will be covering in this video lecture is induction motor protection. It will be having subtopics like motor protection, types of faults, abnormal operating conditions, overcurrent protection of induction motor, differential protection of induction motor, earth fault protection, and negative sequence voltage relay. This induction motor protection video lecture will be covered in two parts. First part will be covering the first three topics, and the next part, that is part 2, will be covering the protection techniques of this induction motor. Starting with part 1, where we will be studying motor protection, types of fault, and abnormal operating conditions. Motor is an electric machine that converts electrical energy into mechanical energy. We are well aware with various types of motors, which can be classified into DC motors or AC motors. Talking specifically about the induction motor, it is an AC motor which can also be classified into single phase induction motor or three phase induction motor. There is also another classification of induction motor depending upon the rotor construction. That is, it can be squirrel cage rotor or wound rotor. Motor protection. The type of protection used for a particular motor depends upon the switchgear used for its control. Means the switchgear devices used for its starting operation control, stopping operation control, or speed variation control will determine what type of protection technique will be applied to that specific motor. Also, the type of protection used for that particular motor also depends upon the motor size, type of rotor used, type of starter applied, type of load. So all these are the factors which govern what type of protection technique will be applied to that specific motor. Also, this is important, please note it. There are two basic protections which are applied for every motor. These are thermal overload protection and short circuit protection. For thermal overload protection, overcurrent relays are used, and for short circuit protection, HRC fuses are used. These two basic protections are applied for every motor, so you will see these two protection techniques in every motor. Talking about the faults, the most common electrical and mechanical fault seen in motor includes fault on motor terminals, stator faults, rotor faults, and fault on starters and bearings. Fault on motor terminal. Such type of fault produces the fault current which is even greater than your starting current. So, a fast and reliable operation is needed. For this purpose, instantaneous overcurrent relays are used for protection. Stator fault. Fault in stator or motor winding due to any insulation failure or insulation breakdown are generally termed as stator faults. The faults occurring in stator can be face-to-face fault, earth fault, or there can be possibility of interturn fault. Although the probability of earth fault to occur is more or larger, whereas face-to-face fault occur very rarely. Rotor faults. Such faults are seen more likely to occur in wound rotor motors. The thermal and mechanical stress produced due to the rotor faults leads to rotor bars being cracked, and also there can be a possibility of rotor getting damaged, due to which the torque of the motor get reduced. Fault on starters and bearing. Mechanical imperfection as misalignment of rotor or rotor unbalance or failure in the bearings can lead to the fault on starters and bearings. There are some abnormal operating conditions which also lead to fault. These include mechanical overload. It may have like prolonged overloading, means we are overloading the motor for a long period of time, stalling, and sustained overload. These three possibilities can lead to mechanical overload, which further can be deducted as fault in motor. Abnormal supply conditions. This include loss of supply voltage, over voltage, under voltage, phase sequence reversal, or unbalanced supply. If these four conditions occur, then there is a possibility of abnormal supply conditions, and thus a fault can occur in motor. Faults in starting supply circuit. If there is interruption in phases, or a fuse get blows out, or short circuit in the supply, will lead to definitely a fault in the starting supply circuit. Internal faults like phase-to-phase fault, phase-to-earth fault, or mechanical failure or failure in one of the phases or all the phases will also lead to internal fault in motor. Talking some of the abnormal operating conditions discussed, starting with stalling. Stalling is a condition where motor does not start, and the motor does not start because of the excessive overload connected to it, and in this condition the motors draw heavy current, and thus the motor should be disconnected from the supply immediately. Unbalanced supply voltage. Although the unbalanced supply voltage is not that much harmful, but the negative sequence current produced due to as a result of this unbalanced supply voltage will cause many problems, and thus like rotor heating and temperature increase, and which may lead to insulation failure, and thus in this case of unbalanced supply voltage the motor must be disconnected. Overloading. Prolonged overloading means we are overloading our motor for a long period of time, which may lead to temperature rise in winding and deterioration of insulation. Failure of bearing. This causes locking of rotor, and thus the bearing should be replaced and the motor should be disconnected. Single phasing. It is a situation or condition where one of your supply lines get disconnected due to blowing of fuse or open circuit condition. Thus the whole power is then supplied through the two windings. Hence, there is a flow of unbalanced current which can lead to negative sequence component of unbalanced current, and hence the rotor heating or the temperature rise occurs, which may lead to insulation failure. And hence, in this condition of single phasing, we need to have a single phasing preventer, which are generally used for large induction motors. Here, these single phasing inverters are connected to your secondaries of CT. These contain a negative sequence filter, the output of which is compared with the help of a level detector. The negative sequence current so produced is compared with a preset or predetermined value, and if that negative sequence current is greater than your preset value, a relay command gets activated, and thus the motor is disconnected from the supply. Thank you all. That's it for the first part. We will be ending our first part here only. For the second part, where we will be covering our protection techniques of induction motor, do watch the second part and please stay connected.